Hello everyone. So today we have our ISE activity 1 of solid mechanics, that is video presentation. So myself Vedant Yeole. I am from Aeronautical Engineering Department. My URN is 1024071008. So today my topic is about effect of bending stresses on lightweight aerospace trusses. Now let's discuss about the introduction part of the topic. So we can say basically aerospace structures demands lightweight and yet strong materials for reliability and efficiency of the structures. Then we can say trusses are key due to high strength to weight ratio. Basically it has high strength to weight ratio. Then we can say bending stresses influence safety, reliability and efficiency to the structures. After that we can say it is critical for aerospace design optimization. So it is basically critical for aerospace design optimization. So what is basically bending stresses? So we can say bending stresses occurs due to external loads caused bending moments. Like when external load is putted on it, bending moment is caused disturbed. Then one side experiences tension, other side is compression. We can say that also. And it is important in trusses subjected to aerodynamics and structural loads, etc. So now let's talk about the stress distribution in bending. So there are three imaginary axes: neutral axis, above neutral axis and below neutral axis. So in neutral axis it is a line of zero stress, means zero stress is applied there. Then above neutral axis the compression zone is there, means compression is applied. Then below neutral axis the tension zone is there, means the tension is applied there, the tension zone. Then we can say here lightweight members face higher stress concentration than others. Then let's discuss about the sources of bending in aerospace trusses. So we can say aerodynamics forces from lift and drag. Aerodynamic forces are the sources of the aerospace trusses, bending in aerospace trusses. Then payload or fuel uneven distribution of payload and fuel. Then thermal stresses due to gradients. Then vibrations and turbulence due to some issues in the structure. Then or when landing or that. And manufacturing and assembly imperfection, etc. Now let's talk about the effects of bending stresses. Means what it causes. So it causes crack initiation and fatigue failures. So it causes fatigue failures. Then it causes in reduction in load capacity of the structure. Then permanent deformation of the structure. Then buckling of the slender lightweight members. Then loss of aerodynamic efficiency in the structure, means it loses the aerodynamic efficiency in the structure itself. Now let's talk about our next slide, that is effect on fatigue life. So like I said in previous slide, that effect of bending stresses, it causes crack initiation and fatigue failure basically. So it is a part of fatigue life, effect on fatigue life. So we can say that it repeats bending cycles that causes fatigue damages. Then we can say microcracks form at high stress regions. Microcracks are formed in high stress regions on the structure. Then we can say it reduces all over lifespan of the aerospace structures. It reduces all over lifespan when it is fatigue. Then we can say it inspection and fatigue analysis are critical in that situation in fatigue life. Now we'll go our next interesting part, that is our next slide, that is analytical and simulation tools. So basically we can say it is there are simulation tools that we can study about the bending stresses and all. So classical beam theory for initial design, we can apply the classical beam theory for initial designs of the aerospace structures. Then finite element analysis, that is FEA, for accurate stress mapping of the structure where stress is applied at the point. Then computational fluid dynamics, you can say CFD, to analyze aerodynamic loads on the structures, on the parts of the structures. Then experimental validation via wind tunnel and vibration testing. So we can experiment validation via wind tunnel on the vibration testing. We can vibrate it, then we can test it. Now let's move on to the next slide, that is case example. So we can take an example to understand it purely. That is, we can take a wing truss under load. That example we are taking now. So the upper truss members in compression. So we can say that upper truss means the upper part of the truss are in the compression. Then the lower members in tension means the lower part of the truss are in the tension, and tension is applied there, and in upper case the compression is applied there. Then we can say diagonals resist shear and bending. So on the diagonals it resists on shear and bending stresses. Then it shows critical role of truss geometry in load distribution. So it shows critical role for truss geometry. It shows the geometry of the truss in load distribution of the structure of the aerospace. Now in this slide we can see the visual representation of the effect of bending stresses on lightweight aerospace trusses. So we can see that here is the bending stress is applied. This is the visual representation you can see. So let's move on to our next slide, that is our conclusion. So basically we have concluded that bending stresses strongly affect aerospace trusses safety and performance. So when the bending stress is applied, the safety and performance of the aerospace trusses are strongly affected for sure. Then we can say lightweight materials increase vulnerability to fatigue and buckling. Then we can say proper material selection, geometry optimization and simulation mitigate the risks. So if you don't choose the proper materials, simulations and geometry to proper manner, then it can cause the risk. It increases the risk. Then we can say ongoing innovation ensures safer, more efficient aerospace structures. So we have to save our nation, our structures with aerospace structures, and we have to innovate something new. At the end, I want to say thank you to all of you for listening and understanding me patiently. Thank you.